Good morning everybody. In this class we are going to discuss about the analysis of a transistor amplifier using hybrid parameter model. Okay. So let's see a circuit diagram. Actually it is a transistor amplifier circuit and transistor connected in a circuit in C mode configuration because the emitter terminal of the transistor is common to both the input and output load. So this is the C mode configuration. So this is the CE amplifier. Okay, this is the biasing voltage and this is the biasing resistance. Actually these are used to bias the transistor to establish the operating point at the suitable location of the transistor. Okay, actually transistor is a nonlinear device, but it behaves as linear in the active region. So to place the operating point at the middle point of the active region or at a suitable position of the active region linear portion, we have to bias the circuit. Okay, so here the biasing voltage and biasing resistance are used here. This is the AC source that provide the AC signal to the amplifier circuit for the amplification, and this is the source resistance. And this is the coupling capacitor or blocking capacitor. Actually this capacitor behaves as a short circuit for the AC signal, so the capacitor easily couple the AC signal to the amplifier circuit, but it blocks the DC signal, and it is very necessary to block the AC signal because no AC source is pure AC. There is finite DC also. So the presence of the DC may change the position of the operating point. Okay, so for better amplification, for stable amplification, for undistorted amplification, the position of the operating point is very vital. So the coupling capacitor or blocking capacitor is very important. There is also another coupling or blocking capacitors. Both the capacitors have same roles. Okay, and this is the load resistance and this is the supply voltage. For the analysis of the transistor amplifier, first we have to replace the circuit in hybrid parameter, equivalent hybrid parameter model. Okay, already we have discussed about the hybrid parameter model circuit in the previous class, and this is the hybrid parameter circuit only for the transistor. There is a input impedance, there is a voltage source HRV0, and this is the current source HFIB, and this is the output impedance 1 by AG, just only for the transistor. Okay, here emitter is common, this is the base and this is collector. So this is the H parameter equivalent AC equivalent circuit for the transistor only. So in addition to the hybrid parameter circuit of the transistor, there is a AC signal that to be amplified, and this is the source resistance, but there is no the biasing resistance. Okay, actually biasing resistance having value very higher, and since it appear parallel to the input terminal, so it behaves open circuit. Okay, so the RB is not connected in the AC equivalent circuit, and this is the load resistance RL, and we get the output voltage across RL. Okay, here the input current is the base current IB, this is the input impedance. Okay, and here the output current is the I0, or it may be collector current. Okay, now first I will calculate the current gain. Okay, current gain, yeah, it means load current by input current. This is the load current, but actually current flowing in that direction I0. So IL can be represented in terms of I0. IL will be minus I0. So write here minus I0 by IB. Okay. Now from this loop we can write I0. What will be the value of the I0? I0, part of the I0 is flowing through this path. So this is FEIB and another one through 1 by HV, and voltage across 1 by HV is V0. So V0 by 1 by HV means V0 HV. So this is the I0, and V0 equal to the voltage across the RL is the V0, okay, and V0 is equal to IL into RL, and IL can be written as minus I0. So minus I0 RL is the V0. Now substitute the value of V0 in that equation, then get HFE IB, substitute here minus I0 RL HY. So this is I0, or I0 plus I0 RL HY is equal to, after rearranging the equation you can write this, and I0 is equal to 1 plus RL HY, this is equal to HFE into IB, or I0 is equal to HFE by 1 plus RL HOE into IB. Okay. Substitute the value of I0 in that equation, then we get current gain equal to minus HFE by 1 plus RL. Okay. So this is the current gain. Here negative sign signifies that 180 degree phase difference takes place between the input and output. So it is called inverting amplifier. C amplifier actually the inverting amplifier. Okay. Now I will calculate the input impedance. Input impedance. Input impedance. Okay. From the circuit we can write the input voltage VI equal to, see here, VI is equal to HI IB plus HI into V0, voltage provided by the voltage source and the voltage drop after the input impedance. So this is the VI, or HI IB plus HRE, we already know V0 is equal to minus I0 RL. Okay. This is equal to HIB plus HRE. From this expression we can write minus I0 is equal to AI into IB. Okay, minus I0 is equal to AI IB into RL. Okay, can you write AI here? Minus I0 is equal to AI into IB. So we can write in the position of the minus I0 AI into IB into RL. Okay, so if we take common IB, then it will be HIE plus HRE plus AI into RL. Okay, so the V input voltage by input current, this is the ZI, and this will be HI plus HRE AIRL. Okay, so this is the input impedance. Now I will calculate the voltage gain. Okay, voltage gain. Voltage gain AV equal to V0 by Vi. Okay, ratio of the output voltage by input voltage is the voltage gain, and V0 is equal to minus I0 RL by Vi is equal to input impedance into input current. Okay, this is equal to minus I0, we already minus I0 equal to AI into IB. Okay, I can write AI into IB is the minus I0 into RL by ZI into IB. IB to be cancelled, so AI RL by ZI. This is the voltage gain. We already calculate the value of the AI ZI, so we can substitute the value of the AI and ZI in the expression and we get the expression of the voltage gain. So this is the voltage gain. Okay, now I will calculate the output impedance. Output impedance. Output impedance actually for the calculation of the output impedance we have to replace the AC source by input resistance of the source and remove the RL. So the output impedance Z0 is equal to V0 by I0 and Vs will be 0 and RL will be infinity. Okay. From input loop we can write Vs equal to, actually IB current flowing through both Rs and Hi. So the voltage of due to the IB current is Rs plus Hi plus HRE V0. Okay, and the I0 equal to, from the output loop here, I0 is equal to HFE IB plus HOE into V0. Okay, so this is the output current. From the above equation, if we substitute V is equal to 0, then we will get IB RS HI plus HR V0, or IB equal to minus HRE by RS plus HI into V0. Substitute the value of IB in that equation, in this equation. Okay, then I will get, substitute the value, so minus HRE HFE by RS plus into V0. Okay, plus this term and first term and this is second term and this is HRE into V0. Sorry, HOE into V0 from this term. Actually I am writing the this expression. Okay, here substitute the value of IB. So HFE into IB means HRE by RS plus HI into V0, and already there is HOE V0. Okay, so if we take V0 outside, then we can write HOE minus HRE HFE by RL plus H. Okay, or the output impedance Z0 is equal to V0 by I0 is equal to 1 by HOE minus HRE HFE by RS plus H. So this is the expression of the output impedance. Okay, and these are the performance quantity for C amplifier, and what will be the C mode amplifier. So what will be the other cases for CB or CC? For any mode of operation, the expression will be same, just we have to change the parameter. Okay, so this is the current gain. If we calculate the performance quantity for CC amplifier, then the expression, just I have to change the parameter, so it will be, the expression will be same, only we have to change the parameter. So it will be HFC, it will be HOC for CC mode, and for CB mode it will be HFB CB mode, HOB. Okay, similarly this will be HIC, it is for C amplifier, but for CC amplifier it will be HIC, HRC. Okay, and for CB amplifier it will be HIB and HRB, but the expression remains same, does not change the expression, just we have to change the hybrid parameter. Okay, and similarly for the output impedance for CC amplifier, HOC, HRC, HFC, HIC, and the same for CB, HOB, HRB, HFB, HIB. Okay, we can also simplify the hybrid parameter AC equivalent circuit, because the value of HRE is very small. HR is very small, tends to 0. Okay, so you can neglect the voltage source. This term will be very smaller. And another, HOE is also very small, tends to 0. Okay, and since here APR parameter of the load 1 by HOE, so HOE is very small, so mean 1 by H will be very high, tends to infinity. And since it appears parallel to the load, so it behaves as an open circuit. Okay, so the simplified hybrid parameter model circuit can be written as, just I have to write the input impedance, and using it we can easily calculate this is the hybrid parameter model for just for the transistor, and for this is the hybrid parameter model for an approximate hybrid parameter model HFE, IB and IB. And if we consider the above circuit, then the simplified circuit we have to write here the RS and VS, and here Okay, and by using this simplified H parameter model circuit, we can easily calculate the all the terms. Okay, next class I will calculate the performance quantity, that is current gain, voltage gain, input impedance, output impedance, using this simplified H parameter equivalent circuit. Okay.